I just wanted to catch up with you again. This time, wanting to just continue the section we started in our previous unit on perimeter. The last time we spoke, we talked about the perimeter of regular shapes, like a square. And we found out that if you have a square, you have 4 equal sides, and if you should take a walk around the outside edge of a square, you're simply going to be multiplying 4 sides, and you can use that formula for a square. If you have a rectangle, on the other hand, you have 2 widths, 2 lengths that are different in rectangle. In the case of a triangle, unless you have a special triangle, like an isosceles triangle, or maybe an equilateral triangle, you are pretty much going to be looking at just adding up all the different sides. So you're going to say side plus side in case they're all different for your perimeter of your triangle. What I want to turn to now is a shape that's actually a little bit more tricky to understand in terms of perimeter. So the first thing I'm going to say is that there's a special word that we use for the perimeter of the shape. And you know that word already from last year in year 9 or maybe year 8. That special word starts with a C, and if we were playing hangman, we do it now, but since I can't see you, I'm just going to play my own hangman and beat you. So circumference is the special word that we use for describing the perimeter of a circle. So circumference isn't a strange word. It's just a word that says I'm taking a walk around the outside edge of a circle, and that outside edge is known as the circumference. Now, we already know 2 things about a circumference, and that is that it's a word particular to circles, but it's not a word that stands alone when it comes to circles. This one you might be familiar with. Starts with an R, that's your radius. And then we've got this other one, which is your diameter. Now, both of them can be found in the formula for a circle. So if I take the radius, I'm going to take 2 multiplied by pi. That special value lives inside your calculator's brain, times your radius. Or, depending on the information you've got, you can say, I'm going to find the circumference by saying pi times the value for my diameter. So if we're looking at those 2 types of formulae, we could take maybe one example just while we're working with the formula and say, if I gave you a circle with a radius of 8 centimeters, what would you do? Let me just move this page up a little bit. You'd be able to say, I know the formula for that. I'm going to use 2 pi r. Once I've got that, I'm going to take my 2 multiplied by the value embedded in my calculator and times it by the radius which I was given. Now, when you take a look at your calculator, I'm just going to put it here on the side. When you take a look at your calculator, on my calculator, the value of pi is embedded in the second function right there at the tip of my pen. So for me to access it, I'm going to just clear my calculator. I'm going to say 2 times second function pi times the value for my radius, which was 8. And I'm going to get my answer, which is 50 point, well, let's round it to 2 decimal places. I'll call it 27 centimeters. And because we are just doing circumference, not area, the unit just remains centimeters. So that's how to use your circumference formula. But what if I gave you a piece of a circle? What if I didn't give you a whole circle and I say to you, well, this is a whole circle, but I don't want to know the circumference of the whole circle. I just want to know the circumference of a piece of the circle. Now I'm going to color that piece in orange. I just want to know the circumference. There's my 2 radii and this little thing known as the arc. So if I take my formula, which I now have, I'm now going to first have to find out the one thing I don't know, which is the arc. So there's a special formula which we use to find the arc length, which is the one on the very outside edge. And just for the purposes of what we're doing, how about I make my arc length a blue one? I'll circle in blue. So there's our arc length. To find an arc length, because it's only a piece of a circle, I'm going to say the angle, which I'd have to know or be given, divided by 360 degrees, because I've only got a piece of the circle, and I'm going to multiply that by the same formula which I already know, 2 pi r. So that will give me the arc of my circle. That's not going to give me my whole perimeter of my slice of pizza. In order to do that, I'm going to need to know also the value for this r and the special fact that a radius will always be the same no matter where in the circle you take it from. So let's see if we can solve a problem with a sector of a circle. So here we've got a sector, and we're given a 72-degree angle in this case, and no other information other than the 10 meters of a radius. So obviously we've got to do 2 things. Firstly, we've got to find the same thing that we just found. We first have to find that arc length. Remember, last time we said if I want to find an arc length, I need to do a special formula. So this time I've got my theta, which is right here. My theta happens to be 72 degrees, which is a piece of my whole circle. So it's a fraction of the circle times 2 pi, what's the radius that was given? 10 meters. So if I look at that space, I'm going to be given the arc length, but that's not the entire perimeter. In order to find the perimeter, there's 2 more things I'm going to need, isn't it? I'm going to need to add the length of that radius and the length of that radius. So do you understand when I say, I'm going to say plus 2 times those 10 meters, right? So on the one side, I'm first doing just the calculation of the arc. And then I remember, actually, I have to also walk around the radius and the other radius. So I'm adding those 2 radii in as part of my sum. Okay, I'm going to move that to the center a little bit. At this point, you might be thinking, oh my goodness, this is such a big sum. But how about we make our life a little bit easier by making our calculations smaller. So if I take purple, just so it's nice and dark, I'm going to take my 72 degrees and divide it by 360 degrees. I get 0.2 as my decimal. I'm going to go ahead and say times, I've got a value of 2 times pi times 10. That's going to give me a 62.83 plus 2 times 10, we don't need to calculate for that, is 20. See, the sum becomes completely more palatable. I'm going to leave that long number embedded in there with all the decimal points. Add the 20, which is the 2 radii, to that. Get another answer, but I'm mustn't forget about the 0.2